Yo, 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 yo. Anxiety is a beach. But today we are working on, we're going to continue that pickpocket thing and try to knock something out here. How you doing? Welcome, welcome. I'm a little late, huh? It's scheduled for 7:30. Well, shit. That's all right. How's everyone doing today, huh? All of you viewers here. Oh, man. You're doing great. It's cool. So, this is where we left off yesterday. We got our little guy. Of course, he can't fucking crouch because for some reason it does not want to save this mapping. I don't know what I did. Maybe, like, if I just duplicate this or something. And do the IA map move, IA crouch. Maybe that will help, but it's just not saving this. I don't know what I did wrong here. I got a new mesh. Should I change the mesh? Should I change the character here to a new guy? New guy. I made one today. Not for this, but it will work. Here's this. We got, oh wait, I don't want that one. I want, whoops, sorry. I want it from downloads here. We have all this. This is all this guy. And I'm going to put this in a good folder where I'll remember it. Let's do that. Anim. Put that all here. Perfect. Let's do the T-pose to do the base thing here. We want, yes, okay. Let's just do that. Okay. We got our guy here. He's looking like me here. Let's make all this 0. What is it? What do we do? What do we do? What do we do? It's parameter float. How do I do this? Float. Oh, I have to do it on the side or something like that, right? Float. Right. Number. Value. Constant. That's what it is. Constant. Let's just put that as 0. Put that as 1. And do a duplicate of this. Make that 0. I don't really want to change any of that right now. Okay, let's just make sure he's not so shiny, huh? There we go. Same thing with this one. Just copy these little values here. Do this. 1, 0. Okay. No longer shiny. Now we got our little guy here. Let's go. Folder, anims. I made this guy here, so that's why I'm going to use him, because he looks kind of like me. Alright. Let's change the mesh to this guy. Can I just use the same anim blueprint? Oh no, of course not, because that's not it. Okay, let's go here. Selected game mode. Let's do pickpocket game mode. Create a new blueprint. Pickpocket game mode 2. Okay, we're doing BP third person character 1. Everything else the same. Oh yeah, we are looking good here. He's giant, huh? He's giant. Alright. Well, for now, let's just do let's get the mechanic done. We can bring this guy in later if we want to. So let's go back to, I'm just so mad that it kept doing that thing, huh? Okay. Compile. Are we gonna crouch now, sir? Oh, we have no animation. Why? Yeah, there should be animation for sure. I see. Alright, whatever. We'll fix it. We'll fix it. We'll just do the normal one. We'll just fix it later. Of course, this is still going. I'm just going to put it in like the... Just put it in the C++. Then it will never go away because it's compiled into it. There's something wrong with this. I'm just going to fix this now and we'll fix this later. Alright, so we crouch. We can walk around. And we want to be able to come up to this guy and pickpocket if we're crouched and he doesn't notice us. So first I think we have to make him notice us. Okay. So my idea for that is nothing yet, but we're going to go on Paint and we're going to figure out what does it look like when someone notices you. Wow, it's like a girl's thing. So we do a cone of vision, right? Where he sees, you know, basically we see if he sees it. If there's something blocking it, he can't see you. That's like the standard, right? So you do like kind of a sweep, right? Between from here to there. Is there like is there already a pre-made cone of vision in Unreal? Let's check it out. Unreal AI cone of vision. Visible cone of vision. I don't even need a visible one. Two separate objects versus the visual cone, static mesh. Okay. AI peripheral vision. Stealth vision cone. Oh, that's like what this is like. See, this is, I don't want the, I just want the AI vision cones. Cone check decorator node.
Cone check node, like other decorators, can be added onto a composite node or a task node by right-clicking, going to add decorator, and choosing the decorator you want.
Hi everyone, my name is Paulo Souza, and today I'll
Behavior
give you an
trees.
overview of some of the AI features that come with the Unreal Engine. To demonstrate that, we've built this very simple stealth game, and we're going to use that as a basis for our enemy AI. We've built some visual features in the sector, like the laser light effects you're seeing. Those will serve as a visual cue to the player, representing the enemy's visual cone and the current AI state. We have also built an actor that can be thrown, like a rock. We're going to use this to demonstrate how to make the AI aware to noises. Without that said, let's start. Creating AI in Unreal is facilitated by the gameplay framework, a built-in set of features that helps organizing the logic and interaction between entities in your application. For us to understand the AI framework in Unreal, we need to understand the relationship between pawns and controllers. A pawn is a type of actor that can be an agent in the world, and every pawn can be possessed by a controller. The pawn is the body in our analogy, and if the pawn is the physical representation of an agent in the world, then the controller class will be the soul, where we can set rules for the pawn's behavior.
Here, I turn on
the
subtitles.
Analogy, then the
so
behavior tree, which usually runs inside a controller, would be the brain, the object that actually makes the decisions and command the controller to do things. And finally, the blackboards exist to support the behavior tree with data it can use to make decisions. The blackboard serves as the brain's memory in our analogy. Let's
Okay, then we have the controller, then we have
continue to set up our
brain.
pawn to have an AI controller and create our first behavior tree. Before we start, we make sure our enemy pawn has a pre-configured AI controller class. We're going to use a clean AI controller blueprint for this. Then, we're going to create our first behavior tree, which we're calling NVT.
Okay, let's do this. Let's do this with this guy here, huh? So we're going to our AI. Where do we put that? AI. We're going to create a behavior tree. We'll call this BT, NPC, whatever. All right.
After that, we are ready to configure our AI controller to run that behavior tree we have just created.
Okay, so now AI controller. We go back over here. On begin play, we run behavior tree. Okay. And we use the one we just created. Okay.
Double-click our behavior tree, and we're ready to start. But what is really a behavior tree? Behavior tree is a model that describes switchings between a finite set of tasks that allow developers to create very complex logic composed of these simple tasks. It's built as a hierarchical set of nodes that control the flow of decision-making of an AI entity. It's very easy to expand without worrying how simple the tasks are implemented. It's also easier to understand in code, it's very easy to debug, and it's widely used across the industry, and that's why we're going to talk about this here. You will usually find four types of elements in a behavior tree: composites, decorators, services, or tests. Composites define the root of the branch and the base rules of how the branch is executed. Decorators are also known as conditionals. They define whether or not a branch in a tree or even a single node can be executed. Services will execute at their defined frequency as long as the branch is being executed. And tests, which are the nodes that actually do things, they can have decorators or services attached to them too. It's very important for you to understand how the execution flow of BTs work. BT branches are executed in order, from the top to the bottom at the higher level, and from the left to the right at the branch level, which means that branches to the left have execution priority over the branches to the right. That's important to understand before we can start organizing our decision-making tree.
Branches to the left have execution priority. Okay.
In order, from the top to the bottom at the higher level, and from the left to the right at the branch level, which means that branches to the left have execution priority over the branches to the right. That's important to understand before we can start organizing our decision-making tree. It's also very important for you to understand the difference between composites, sequence and selector. A sequence composite executes every child or branch in order until one of them fails. A selector composite finds and executes the first child that does not fail.
Easy.
What it does, it makes sequence composites very useful when you want to execute a list of tasks one after the other, but need that the entire branch of tasks to be cancelled if one of the tasks fail. The selector, meanwhile, are more useful when you need to make a decision and select which task or branch you want to execute based on, let's say, a set of parameters. We're going to make it much easier to understand once we start demoing this. So let's do it. Let's start by adding a sequence node. From root, only composite nodes can be added. After that, we're going to add 3 tasks by copying and pasting it and connecting to our sequence composite node. As we said before, you can see that we have 3 tasks that are executed in order, one after the other. Let's then select one of the tasks and add a decorator that forces it to fail. And what we're seeing here is that since the second task in that branch fails during execution, the entire sequence node is aborted and none of the tasks to the right are ever going to be executed. Okay, but what if we change to a selector composite? As we know, or the order of the execution. And if we play the game, you can see that since the first task will always fail, the selector composite actually tries to execute the next child. So let's start building our AI. We will create a sequence node and add a few actions, like wait and move to tasks. If we play the game as it is now, our move to task will always fail, because this task.
Okay, so we do a sequence. All right, easy. We'll do a wait. Let's just like this guy did. We'll wait for like, we do like a random. Okay, so let's do like 1, the random deviation of, let's do 2, the random deviation of 1. Okay. And then let's do a move to. And, all right. And then we'll do another wait, I guess.
Task specifically needs a vector variable to be set to work. For that, we're going to need to set up a blackboard and create that variable. The blackboard is a place where we can store data to be used for decision-making purposes.
Okay.
It can be used by a single AI pawn, and some variables can actually be shared by a squad of AI entities. It can also be used with behavior trees, but behavior trees don't necessarily need to use blackboards to work. To create a blackboard, right-click the command browser, then find Artificial Intelligence Blackboard. Later on, set it as your blackboard on your behavior tree. After that, we will create a new key of type vector value. We're going to call it patrol location, and we're going to use it.
Okay, new vector, control location. All right.
To store location data for this behavior. To write the value to our blackboard, we're going to create our first behavior tree task. Create a new blueprint object based on BT task blueprint base. To implement the tree task. Create a new blueprint object based on BT task blueprint base. To implement.
All right, let's see. BT task blueprint base. All right. BP task.
Logic when this task is executed.
Yeah, random location. Okay.
Override the receive execute AI.
I don't even see that.
Event.
Okay.
Let's start by adding a set vector parameter value.
Okay. Set vector parameter.
And let's promote the blackboard key in this function to a variable.
Oh, whoa, whoa, whoa. Set blackboard. Value as vector. Okay.
We're calling blackboard key. Let's add a random location node.
Then we go here. We can do get next point. Can we do that?
Let's set the origin to the control pawn location or the AI entity location. And don't forget to make the radius of that random node a variable too. Both radius and the blackboard key variables, they have to be
Oh,
marked.
let's just do it this way. Maybe we don't even need fucking points, huh? This guy's got it down, huh? Alright, so getting a random navigable. Okay, so this is get random location and navigable radius. Alright. So we're going here, we're going here. Okay. Oh, but this is like... Alright, sure. Okay, let's get the actor location. Okay. That is the origin. Radius is a variable. Okay. What else we
Marked
got?
as public and visible, so we can change them later in the behavior tree. After we compile and save, we can see that our new task
Okay.
get random location is already on the list.
Okay, so now we have some kind of task or something on here. Oh, wow. Okay.
And that we can also customize those variables. We're going to set our Blackboard key as the patrol location. But if we play the game, you see that task get random location is actually never finishing the execution.
I don't actually see this
And the reason for that is
Blackboard
that-
key patrol location. Is there a reason that it didn't show up? Okay, we have that. That's fine. Here, I don't see any Blackboard key. Maybe I need to close this. Open it back up. Or what is this? Okay, it's not showing up, huh? Okay, there's that. Now let's do a new key. Vector patrol location. Save that. There we go. It didn't save as the name, huh? But okay, that's fine. So now our default is patrol location. Alright.
Every behavior tree task has to finish with a game. You see that task get random location is actually never finishing the execution. And the reason for that is that every behavior tree task has to finish with a
Okay, so you have to finish execute. We're getting here. We're learning some Unreal AI here, huh? So you do finish execute, okay? So it's just one task. Alright, so let's do this. Come out this way. All this is together. This thing here. This goes here. By default, let's make this 4. I don't know. Make this 100. Sure. Alright. Save that. Let's do this. We do need to get rid of what we created here, right? So let's just cancel after that. See what happens. Okay, and we can actually see the behavior tree, right? So alright.
failure or success condition, so the behavior tree can control the flow of the execution.
Okay, so now we say success is based on this, right? Let's see. Okay. So now, if we, I feel like this is the next step. You just turn this move to here into patrol location. That's my guess. Let's see how this looks. He's not moving there. All right. Well, it looks like he's looking at it. Okay, let's see what this guy's got in store for us.
Of the other tasks in that branch. So now we're finally good to go. You can see that our enemy is finally patrolling the area, picking a random location around itself.
What's the value that this guy put for
Set it as your blackboard on your behavior tree.
area
Of these tests.
or the range or whatever?
To the behavior tree. To the control pawn location or the AI. After we compile and save pawn location or the AI entity location. And don't forget to make the radius of that random node a variable too. Both radius and blackboard key variables, they have to be marked as public and visible, so we can
You
change
did
them later
1,000.
in the behavior.
Did I do 1,000 also? I thought I came up with that 1,000, huh? I put 100. Let's see if the 1,000 changes anything. No, his speed must be like 0 or something, huh?
Behavior tree. After we compile and save, we can see that our new task get random location is already on the list. And that blackboard key as the patrol location. But if we play the game, you see that task get random location is actually never finishing the execution. And the reason for that is that in the area, picking a success condition, so the behavior tree can control the flow of the execution of the other tasks in that branch.
Oh, and the blackboard key is nothing, huh? That's the issue. So why do we not just make it what we want it? Alright, I gotta get up here in a second. Alright, I see. So now, let's go here. Go back to details. Is it, where is that? Where does it even set the blackboard key?
So now we're finally good to go.
What? Replication, no, okay. No. Blackboard key, none. I don't see how you did that, dude. Let's be real. I don't even see the tasks or anything like that. So here, is there a blackboard or something? Where do I update the blackboard? Instance editable, alright. And what if I just click on it here or something? Okay. Okay, so we're going here. We're getting the location that we're doing the task, and when you do that blackboard key, then it sets it. So let's not expose on spawn. Maybe that's it. Okay, let's just do that. The radius, 1,000. And, okay. You're not moving. You're not going anywhere, huh? I guess we can see the blackboard value, huh? Patrol location is there. And where's our guy? Our guy is at, well, 1,500, okay. So he definitely should be moving, but he's not moving. Let me just do that and see what happens. AI not moving, Unreal. Oh yeah, that's a good point, huh? Okay, yeah, we are having... Oh, so we can actually see the path and stuff, huh? Can I see the path while I'm playing? The move to target was invalid and needs to be linked to the vector variable. Sometimes I don't know whether it's try clicking on the character which is not moving, project nav mesh, okay? Character movement, project nav mesh walking. Alright, let's see. Didn't help. Okay. Check that. Let's see. Project nav mesh. You're not moving, buddy. You were moving before. Now your AI bullshit. Node, move to. Track moving goal, filter class, none. Acceptable radius 5, allow strafe. And this has a value. It's not like it doesn't have a value. No, it says invalid. Okay, yeah, now it has a value. Okay. So, move to is just not moving, huh? Is that because of, well, I know we did this thing here. Is that running? Let's see. Print run behavior tree. Okay, there we go. Compile. True. Okay. So we did run the behavior tree. Branch. Okay, if it's true, then we say hello. All right, let's see. So that part is going. Okay, that's fine. So we're running our behavior tree. We're good there. Now we're here. We're getting a random location. Let's print random location. Print random location. And then we can add like let's just print this value. Let's see if we got a value. Alright, compile, go. True, okay? So that's fine. Delete that. Okay. And so now it's on the move to. We're getting a random location. Now we're doing a move to. Move directly toward. Let's try that. Patrol location. What does that do? Okay, so we're not moving. And for some reason, we're not moving. Okay. We assign a blackboard to the variable of your behavior tree. Have I? Assigned a blackboard to the variable of my behavior tree. Yes. Huh. We're in a real pickle here, huh? That is a difference that was between me and this guy, is I used this node instead. Get random location. Random point. Get random point. Get random point. Let's just try this one. So our origin is this, radius is this, and random location going here. That was the difference. We definitely had a difference, and this is still a difference. But we'll give it a go here. Still nothing. Target is nav system v1. Nav data. It's probably something that I need, huh? That's probably what the issue is, huh? I have a feeling. I have a feeling that that is it. So we got to figure out how to get this nav data, huh? It shouldn't be possible to reference a level blueprint from another blueprint, blah, 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 blah. I guess I could do that. That's kind of shitty. Every time you execute that? Or can I do like a... Let's do this here. All right. Sequence. I'm learning now. All right. So we have nav data. We're gonna get it. We're gonna convert to validated get. If it's not valid, then we're gonna find actors. No. Get all actors of class nav mesh bounds volume. Okay. And copy or get a copy. I said that, yeah. 0 is gonna set can we do like data from this? Nav data. Array element get random point. To get a reference to nav mesh. Get random point. Random reachable point. See, like I'm missing some of the shit that this guy has, huh? Is there not like a navigation data?
Bum, bum, bum. What print out where our character is going to when they move. And we can see this little yellow sphere that indicates the location where they're going to. And if we were to close this, go to here, we'll run, we're going to eject, and then look at our layout and pull up our navigation data. You could see the green is our navigation mesh. And you can see our character running to one of the locations. So it seems
Yeah,
simple
that's right.
enough.
So maybe I just
Let's look
go
at the
to
node.
the Unreal
The node takes
documentation.
in a vector for the origin.
Let me go to Unreal 5.3, and it doesn't exist. Okay. Get navigable. What's it called? Get random location. Get random location in navigable radius. Okay, and let's go here. Nope, that's not even it. Random location in navigable radius. UE5 Unreal Engine.com. There's an option in project settings under navigation mesh. Project settings, nav mesh, okay? And what was it? Is world partitioned? Okay, let's see. Is world partitioned? It's not even an option here. Nope. All right, let's see if my buddy can help me here. He turns toward the position, but just won't move. I mean, I'm thinking it's a collision issue, but that seems kind of stupid. Maybe I should check my speed, huh? Let's see. Max walk speed, let's get it. Let's print it. Not the duration, that's actually the text. Let's see. 600, what was that? Nav data count 1. Recast nav mesh. Okay. We're getting all this bullshit here. .600 is the speed that we are moving. And now we're not getting anything, huh? Okay. Get random location and navigable radius. The thing is, I don't even see a nav data. So we go here, we go to our recast nav mesh default. Nav mesh bounds volume 2. Okay, is that an issue that we had? Some multiple nav meshes or something? Let's try that out. Okay, so now there's this, and there's this. Okay, let's give that a go. Nope. Okay, nav mesh, let's see what your issue is here. Fill collision can ever affect navigation. Hold out. I don't see it as an issue. I'm about to just say, hey, instead of getting a random location, let's just get one of these fucking points. So let's see. Let's change this to patrol point. Okay. Change variable, that's fine, okay. Now we're getting all actors of class patrol point. Alright. And we are just going to do that. If it's null, we have that. Okay. Then we're literally just going to say, I will say current index. Well, let's just get a random fucking point, which we already did. So we say this, get that. We're going to say get copy. Get a copy. Yeah, that's it. Okay. Of this. Oh, because this is this. Alright. There we go. Don't even worry about that. Let's do this. There's that. Out. We'll set this there. Easy. Bing, bang, boom. Bing, bang, boom. Bing, bang, boom. If this is null. Okay, so we say count less than or equal to 0. Branch. Okay, we do this. If it's true, then we do this. Okay, then we're going here. We're going to get a random int. Max is this. Something like that. That's a little messy here. And go there. Oh. Get actor location. Alright. There we go. And we'll just say success. Alright. Okay, so I know for a fact it's something fucking stupid. Because this was 100% working. So like if I go back here, and you know I just connect it as we did. As we had. Oh, wait. Wait. Whoops. No, this is not it. Is this real? We shall see. Yeah, that's classic fucking retard. Oh, whoops. Okay, well, yes. There's that. So, we can just... let's just do this. Let's get rid of that. Let's get back to where we were. Get navigable location in the radius. The origin is location. Get actor location. Okay. Here. The radius is our big boy here. Alright. And that is classic. Classic embarrassing right there. Go here, go there, and go everywhere. And let's see if you work now. Oh no. Okay. Doesn't work. So, maybe I wasn't that dumb. We got some points here. You just stop working again, huh? What the hell? Did I not save or something? Oh, okay. Okay, let's keep this. Okay. Get random location and navigable radius. Alright. Origin is our big boy. Radius is our big boy. Here. Origin is our location. Nope. Get actor location. Nope. Can I just do get act loc? Get actor loc. There we go. Here's that. Just put that here. Put that here. Put that here. Compile. You're saved. Alright, you're not ticking anymore. Okay. What a mess. What a mess, huh? We got you, though. Now I can go around and sniff your butt. Alright, so we got our AI moving around to a random location after fucking 20 minutes. Alright, now.
So in this case, I'm...
Did I lose the video that we were watching? Oh no.
You can see that our enemy is finally patrolling the area, picking a random location around itself every time the behavior tree cycles. We're going to call this our patrol behavior. Let's now add another behavior to our AI. We've mentioned before that selector nodes.
Because you can like rename the sequence. All right, so let's do patrol. All right, there's that. Okay.
Behave differently, and that you can use them when you need to pick a single branch to execute. But if you play the game, our selector node would just pick its first child. But what if we add a higher priority child with a valid task? Well, it will only select that branch. And I know I'm risking being repetitive here, but that's really what selector nodes do. So as we said before, the selector node would try to pick the first branch that doesn't fail. So what we really need here is that this first branch to fail, given a certain condition. For that, we're going to use a decorator node. And the decorator node we're using is the blackboard-based condition.
Okay, so we're doing a sequence over here. Okay. You do a decorator node.
It checks if fail, given a certain condition. For that,
Add decorator. Blackboard.
we're going
Base
to use a decorator
condition.
node. And the decorator node we're using is a blackboard-based condition.
Okay. Add decorator blackboard base condition. All right.
It checks if a blackboard key is valid. For this behavior, we're going to create a new blackboard key called target actor. We're also going to set it as an actor.
Okay. So let's do. Well, I already have this kind of. Let's just do target actor. Easy fix right there.
So we can reuse its location in other parts of our behavior.
What did you change it to? What?
In our decorator node,
Slow
we're now going
down.
to
Slow
select our
down two
target actor
times.
it as an actor, so we can reuse its
Base class, key type actor, base class. Okay, yeah, that's good.
location in other parts of our behavior tree. In our decorator node, we're now going to select our target actor. And since the target actor was not set, that conditional will always fail. So the selector node now picks the next child. Now we will be able to switch between these different branches by setting that blackboard key using the perception system. The AI perception system provides a way for pawns to receive data from.
So since target actor is null, let's visualize this too here. All right. Since it's null, then we move to our place. All right, perfect.
The environment, such as where noises are coming from, or if the AI was damaged by something, or even if the AI sees something. This is accomplished with the AI perception component that acts as a generic stimuli listener and is able to gather stimuli from other actors. Let's now open our enemy AI controller and then add an AI perception component.
Okay, so here, add AI perception. All right.
Inside that, we're going to add a new sense. We're going to use the AI site config.
New sense AI site config.
And then configure our sense site radius
1000, 1000.
and the angle.
45. All
We're
right.
going to do some workaround. We're going to have to select all these items because the detection by affiliation feature is not currently exposed on blueprints. And the last workaround is to edit the config default.game.ini and add these two lines to make sure be exposed on blueprints. And the last workaround is to edit the config default.game.ini and add these two lines to make sure that only the pawns we want will be detected by the perception system. And the reason for that is that we want to select those actors manually. For this, we're going to use this component, the AI perception stimuli source. And then we're going to add the senses that we want the perception system to detect in this actor.
Okay, so we auto register as a source. AI site. All right.
So let's now get back to our enemy AI controller. And then on our AI perception component, we're going to use the on-target perception updated event.
Okay, so you can actually do events like that? How did you do that? Wait, how did you do that?
And then on our AI
Add event. Oh. Okay, easy.
perception component, we're going to use the on-target perception updated event. Then we're going to get a blackboard and set value as an object. So then we're going to get a blackboard and set value as an object. So the blackboard key name we want to write to is the target actor. And the object value is going to be the actor we have just detected.
Okay.
Let's get back to our behavior tree and do a few things. Let's change. And the object value is going to be the
Okay, so you actually just have to write string or make literal name. All right. Alright, and we call that target actor. Alright.
The actor we have just detected. Let's get back to our behavior tree and do a few things. Let's change the wait time. Let's add a move to the target actor. And a really nice feature is that you can actually
move to target actor.
rename those nodes to something that makes more sense for later reference. Our enemy pawn is pre-configured with a blueprint interface that uses an enum to switch between different states, neutral, investigating, and alerted. This changes the lighting effects, colors, and serves as a visual cue to the player. To be able to change that from the behavior tree, we're also going to create a new behavior tree task that calls that same function using a blueprint interface.
Oh.
And now, you just need to add that new task to the branch and select the proper state for that behavior.
Alright, move toward. Move to. I was doing move directly toward. Alright, and that is toward our patrol location. Alright, let's try that again. Alright, cool. So now he's like following me or something. Alright, so let's see if we can stealth it up here. Okay.
We have now covered most of the features of Unreal's AI framework. Just need to add that new task to the branch and select the proper state for that behavior. And now, you just need to add that new task to the branch and select the proper state for that
Task.
behavior. A blueprint entry to the player. To be able to change that from the behavior tree, we're also going to create a new behavior tree. Changes the lighting effects, colors, and serves as a visual cue to the player. To be different states, neutral, investigating, and alerted. This changes the lighting effects, colors, and serves as a visual cue to the player. To be able to change that from the behavior tree, we're also going to...
How do I interrupt? So we're moving here, but I want to interrupt. Right? On result change. Decorators at 3. Okay, so add decorator. Cone check. That's not what we want. We want, what was it? Mark the decorators at 3 to abort their current. My decorator scope. Let's see. I don't even see observer aborts. Supposed to have a decorator or something. Abort. I don't see a decorator that says observer aborts. Oh, there we go. On value change. Self. Blackboard is not set. Okay, let's see. Something like that. Let's see. Okay, that's good. But it can still see me, huh? He's like a real goon. can get rid of that. Okay, so we'll say, probably doing this a weird way, but let's go back to here. Where are you? Where is this thing? We're going AI. Set value as object. Okay, and we're gonna say let's call this, let's get just the value. So we'll say target, we'll go actor, okay. We'll do this, we'll set target to this, do this here, there's that, Blackboard component object reference, okay. Actor object reference. It fits in here. Oh, whoops, that's why. Alright, there's that. There we go. Alright, so we're setting our target. Then we say target changed. So let's do a quick boolean. Okay. So target changes to false. Okay. So basically, if, so we'll just do this. We'll get target, validate. If it's not null, then we're gonna basically check for line of sight. So we'll create a little function. Well, we'll just make it here. So we'll say, was it raycast or is it line, draw, line trace for objects, do a collision. Okay, line trace for objects, start. We want to get our own position here. Let's do this. Okay, so we're going to do line trace. We're going to say get actor location, self, our location, vector there. The end is plus. We'll say, we can just do transform here. Transform, say transform. Alright, we'll say location. No. Get location. How do you do it? Oh, because we're not on the AI NPC. That makes sense. All right. So that's not right. See, I need to figure out this thing. All right. So if target is not valid, target is valid. I think that's probably just a setting in this AI perception, right? So lose sight radius, peripheral vision. Detect enemies. Dominant sense. If I lose sight radius 10. What happens then? So we're here. You're here. You're following me. You're following me, and then you're still following me. You never lose me, huh? Print. String, hello, hello, hello. Okay, we're here, we're here, we're here. Hello. Okay, so it does stop at some point. So what if say set target change to false? This is so weird. I should just finish the video. Huh? That's alright. AI is such a big pain in the butt here. So just never becoming null, huh? Let's see what this guy does about it.
To create a new behavior tree task that calls that same function using a blueprint interface. And now, you just need to add that new task to the branch and select the proper state for that behavior. We have now covered most of the features of Unreal's AI framework, so let's now talk about debugging. Unreal comes with a built-in visual debugger for AI features, so let's check that. To show the gameplay debugger UI, press the tile key during play. You may have to configure another key in the project settings, then gameplay debugger. Make sure you select a key that works for your keyboard. Let's try the perception system debug mode. You can see that it shows the enemy sight radius and angle, and we are able to see if the player has been detected or not, represented by this green sphere. If you pay attention, even though our player is in the detection area, it takes a few seconds for the behavior tree to be updated. And the reason for that is that the patrol branch is still being executed, even though the blackboard value was already set by the perception system. We can fix this by selecting the proper abort mode in the decorator node. Some decorator nodes can force the end of the execution of itself, abort lower priority branches, or even both. In this case, we will set it to abort everything. And reevaluate the behavior.
I see, okay. So this doesn't need this. Instead, you go here, observer aborts everything. Alright.
Behavior tree from the root. And now, as soon as we enter the site detection area of our enemy, our behavior tree is detected or not, the gameplay debugger features. So let's check that. To show the gameplay debugger UI, press the tile key during play.
The tiled. I think he's talking about tilde. I don't think that's it.
AI features. So let's check that. To show the gameplay debugger UI, press the tile key during play. You may have to configure another key in the project settings, and gameplay debugger.
Gameplay debugger. Activation key is apostrophe. That's this one here, huh? Okay, there we go. Nice, alright.
Make sure you select a key that works for your keyboard. The gameplay debugger presents this UI overlay with information about your enemy pawns and AI controllers, including information from the perception system and the behavior trees. You can change between different modes by pressing the numpad keys on your keyboard. You can also press tab to decouple from your player pawn and the behavior trees. You can change between different modes by pressing the numpad keys on your keyboard. You can also press tab to decouple from your player pawn and fly around like a spectator pawn.
Okay.
Let's try the perception system debug mode. If you pay attention, even though it's still being executed with node, to abort everything and evaluate it, and the right branch is picked almost instantly, getting the eye in the desired alert state. By and head to that location to investigate it. First, revert to our enemy AI. Getting the eye in the desired alert state. Let's now add another behavior to our enemy AI. We want our enemy to be alerted of noises close by, and head to that location to investigate it. First, let's create a new vector blackboard key called target location. AI.
Alright, my back hurts, but we're going to work on this tomorrow. Knock the rest of this out. Sounds good to me. My video was frozen this whole fucking time. Great. Sounds good. I was too far into this. Alright, well, with that, thank you guys so much for watching.